Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 2 until 3 in the afternoon, and we are in our 5th week of our 9-week course. So a reminder that the support questions in your IEL booklet, the ones with the little pencil icon, are not for marking. You decide which ones and how many to do depending on your needs. If you are understanding a concept, feel free to skip questions. You don't have to do them just because they are there. Do whatever is best for you. If you need more practice, let me know and I'm happy to send you more practice. The answers are in the back of your booklet, so please check your work to make sure that you are on the right track. If any of it doesn't line up, doesn't make sense, let me know. Sometimes there are mistakes in the back. Your key questions are the ones with the little key icon, and these are the ones to submit for marking. So please do all of these questions. I'm marking them all, so do them all. Show all of your work, your steps, and your thinking. This way I can know what it is that you know. And also if you're struggling with something, I have a better way of understanding what it is exactly that you're struggling with. So how do you actually submit your work for marking? Well, there's 3 methods. The first is to scan your work and send electronically. If you have a device, you can use an app to scan it. The Apple devices have Notes apps, and the Android devices have a Google Drive app. These are free apps that generally come with these devices, though you can download them again for free. And then they're basically a point and click scanning function. It's fairly straightforward. It's basically just taking a picture and taking out the extra information that you don't need. If you do just need to take a picture to send it, that's fine too. If you want to learn how to scan and you're not quite sure how to do that, feel free to ask for help. Also on my YouTube channel, there are tech tutorials that walk you through how to actually go and use these applications. Then once you have it scanned, send it to me through either email at studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can send it through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We are the bright red building next to the post office. And we have a small white mailbox next to our side entrance that you can just stick your work in there at any time. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work if they have access to a fax machine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa, so you can connect with me there. All of our radio Zoom classes are recorded and I post them to YouTube shortly after airing and share them on Facebook. Also, there are short videos on my YouTube channel that have common errors and confusing concepts explained. So things that I know students often struggle with or are common issues that I've noticed. And I've made short videos there to just address those particular problems. So check that out if you need some help. Math is a really visual subject, so I strongly encourage you to access the videos, either joining me live through the Zoom link. Even if you don't want to talk to me, that's fine, but just watch, go for it, do what you need to do, or watching the YouTube channel on your own time. If you don't have access to reliable internet and this isn't an option for you, let me know and I'm happy to send you a copy of the recordings so that you still have a full experience. So if you have any questions or concerns, please reach out to connect with me. You can email me at bronwyn.slate@nnec.on.ca. You can send me a message on Facebook through bslate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. All right, we are continuing today with lesson 11. In our last session, we did the first part of lesson 11, and now we are doing the second part of the trigonometric ratios. So our learning goals are that you'll be able to recognize and label parts of a right triangle, and you'll understand how to use trigonometric ratios to find unknown sides and interior angles of right triangles. So we will be going over again how to label a triangle today, just to make sure that still makes sense. And in case you're watching this video first and doing the angles first, but then our other video is looking at solving for unknown sides. So you need to check that one out as well. The success criteria is you can identify the opposite and adjacent sides as well as the hypotenuse side of a right triangle. You can solve for unknown sides using trig ratios, and you can solve for unknown angles using trig ratios, which is what we're going to focus on today. But first, let's activate your brain with some mental math. So I don't believe in math minutes. They do not generally help students. They just cause stress and anxiety. So instead of doing that, we focus on developing strategies that are strategies that are transferable and are using your comfort in numbers. So today's question is 82 take away 53, and we're using the strategy of adding up. So we can, adding is something that many folks find easier to understand and to work through. So using that to subtract can be really useful. This is also often how people do things with money. So if you are paying $82, you have to pay $82. No, you're paying $53, but you have $82 to spend that you're giving, and then you're going to get change back. This is often how it's found. People count up like this. I didn't say that very well, but I'll show you how it goes. So you can think on this in an open number line. I've rearranged it just this time to make it a little bit different. You don't have to do anything. So our goal is to get to 82. We're starting at 53, and the difference that we have between them is going to be what our result is. So to get to 82, we're going to use friendly numbers. I'm going to add first 7 to get to 60. And then from 60, I'm going to add 20 to get to 80. And then to get to 82, I'm going to add 2 to get to 82. So the pieces that I had to actually add were 7 plus 20 plus 2, which is 29. So what that means is that between 53 and 82 is 29. So 82 take away 53 is 29. So that can be another strategy that can be really, really helpful. All right, so let's do a recap of what prior knowledge that we need. So again, some more information about triangles is that the interior angles add up to 180 degrees. So the interior angles of a triangle are the inside angles. And so they, no matter what size of triangle you have, they always add up to 180 degrees. This doesn't matter if you have a right angle triangle. So that's 90 plus 2 other angles to add up to 180, or you don't have a right angle triangle. It's just 3 unknown angles adding up to 180. It always A triangle always has the inside angles, the interior angles always add up to 180. And that's all that we need to know that's new today. And we will continue on with looking at trig and specifically solving for unknown angles. So remember that trigonometric ratios are the ratios of any two sides of a right angle triangle in terms of the reference angle. So sine, cosine, and tangent ratios can be used to find both unknown sides and unknown angles. So we're going to look again at what the sine ratio means, what it is, a reminder, also in case this is the first time. And then we will look at how we use that information to solve for an unknown angle. Now, this again is introduced on page 2 of your IEL booklet. This is a repeat if you've watched it, if you've watched the first part of lesson 11, but we're going to go through it again just to make sure everybody has the tools they need. So looking at right angle triangles is what we are doing with trigonometry, primary trig, and knowing that the hypotenuse is always the longest side, which is across from your right angle. This is always called the hypotenuse, no matter what you're doing, primary trig or not. The hypotenuse is across from the right angle in your triangle. Then your reference angle is the important angle in your situation. So whatever your question's asking, one of your angles is the angle that we're talking about, because the same things apply to the other angle, but if that's not the angle you're talking about, that's important. So you always have to know which is your reference angle, and your reference angle is never the right angle. It always has to be one of the other two angles. Then your opposite side is always across from the reference angle. I like to label this OPP. Some people like to write just O, some people like to write the whole word opposite. You figure out what is best for you. So the sine ratio is sine of your reference angle is equal to the length of the opposite side divided by the length of the hypotenuse side. So this ratio, no matter the size of your triangle, always the sine of that angle is always going to be opposite over hypotenuse. And this can be shortened down to sine A equals OPP over HYP is how I always like to write it out. Some people like to use the little acronym SOH, SOA, or SAW, SOH, sine opposite hypotenuse. You do what makes the most sense for you. Okay, so how do we actually use that to find an angle? And this is on page 6 of your IEL booklet. So here we have a triangle that is a right angle triangle. We know one side is 48 meters, and one side is 33 meters, and we have a reference angle of R. So first we're going to label our sides and look that 33 is the side that is opposite angle R, and 48 meters is the side that is the hypotenuse because it's across from the right angle. So we know that sine R is equal to opposite over hypotenuse. So if we fill in the numbers that we know, sine R is equal to 33 over 48. So today we can see we have both side lengths. We don't have the angle R. We don't know how big that angle is. So in order to figure that out, we need to use your calculator. We need to figure out that, or no, sorry, we need to divide. My bad. First, we need to divide. So we do 33 divided by 48, which is 0.6875. I strongly encourage you to use at least 4 decimal places. You don't need to use 8 or 10, but 4 or 5 decimal places you need to have in order to get an exact answer. I'll show you what I mean in a minute, why rounding it more is not going to be as precise. So back in the day, before we had calculators that were super accessible, we had to use these trigonometric tables. And so what you'd have to do is you'd have to look up this ratio to figure out what angle that was related to. So what we're saying is that the sine of our reference angle is equal to 0.6875. So we would find on our chart what is closest to 0.6875. And we can see here that 0.6820 is the closest that we have, and that's 43 degrees. So that means that our angle for our triangle is approximately 43 degrees. That's as close as we could get based on the lists, which is what we had to use before we had calculators that were little computers that we carried around with us. So because we don't all have those charts and that's not the most useful way, we can also use our calculator. And our calculator, the function on our calculator that is tapping into that chart, so your calculator has all of those data points in its little computer brain, and how we access it is we use what is called sine inverse. So it's sine with a little superscript -1, which is saying it's the opposite of sine. So we're going backwards to figure out, we know what our ratio is, and we're trying to find what our angle is that corresponds to that. So how you write it out is you write sine inverse, open a bracket, sine r, close your bracket, and sine inverse, I'll always say it's sine inverse, but it's sine, and then it's like you have an exponent of -1, that's your inverse, it's the opposite. And so that is equal to sine inverse of, open a bracket, 0.6875, close your bracket, and then when you put that into your calculator, you figure out what your angle R is. So how to find your sine inverse button on your calculator is that it's most often, and I think I've only ever seen it on a physical calculator, it is the second function of your sine. So if you look on your calculator, there's above your sine button, there's going to be a little bit of some words, some text, and it should say sine inverse right above your sine button, and you have to find your second button, your second function on your calculator, and press that first, and then press sine to do sine inverse. If you need help with that, let me know and we can figure out what it is for your calculator. But if we go to Desmos and we actually see this in action, on Desmos, it's a little bit different. Here you go to function, and then now it gives you your sine inverse. So how you would type this in on your calculator is you type it in sine inverse, and then you go back to your numbers and you put 0.6875, and then that tells us what the angle is, which is 43.4, which is pretty close to 43, which is what we found out when we looked at the chart. So this is why it's important to put as many decimals as you can, because as you can see, if I only put in 0.6, if I round it to 1 decimal, then that says 36. And if I put in 0.68, now it says 42.8, 0.687, 43.3, 0.6875 is 43.4. So we can see we're getting closer and closer to the same, getting closer and closer to 43 consistently. So that's why doing it with 4 decimal places gets you a pretty exact answer. So what that means is that our angle R is 43.4 degrees, or 43 degrees is how big angle R is, no matter if we're zoomed in really close and our triangle seems really big, or if we're zoomed in far away, if we're zoomed out, our triangle seems really small, that angle is always 43.4 degrees. Last thing to remember, the same as when we were doing things in with our side lengths, your calculator must be in degrees for all of these. Remember how I keep saying degrees? That's because our unit of measurement is degrees. Your calculator has the ability to do different kinds of measurement, which we are not going to learn about, but you just want to make sure often it's easy to make mistakes and be like, why am I getting numbers that make absolutely no sense? They don't match up with the answers in the back of the book. They don't match up with the examples. It's very possible because your calculator is not in degrees. So make sure your calculator is in degrees. Okay, now you can do the support questions on page 6, questions 5 through 7. That is all we are doing. Although we're adding from like yesterday, we did the first part, and now we're adding on the finding the angles. So now let's look at cosine ratio. So the same process. This is still trying to understand cosine, but now solving for the angles once we understand cosine. So cosine works, the cosine ratio is for right angle triangles. And we first need to always know that the hypotenuse still is the longest side that is across from the right angle. And your reference angle is still the most important angle in your situation. It's the one that we're talking about, and it's never the right angle. So that is always still, this is always true. I've said it lots and I will continue to say it, as this information is always true and it defines your question. Then now with the cosine ratio, we're going to look at the adjacent side, which is always next to or adjacent to the reference angle. So it is a side that is beside the reference angle. That's not the hypotenuse. The reference angle is between the adjacent and the hypotenuse sides. So cosine of A, your reference angle, is equal to the ratio of the length of the side adjacent angle A divided by the length of the hypotenuse side. So cosine equals adjacent over hypotenuse. And I write that in my short form is cos A equals ADJ for adjacent over HYP for hypotenuse. Other folks often use the short form ca, C cos, A for adjacent, H for hypotenuse. All right, so now let's how we use that cosine to find an angle. And this is like the example on page 10 of your IEL booklet. So if we're solving for, we have a triangle, we're solving for angle B. We have, it's a right angle triangle, always check. We have one side, which is 85.9 centimeters, and we have one side, which is 37.2 centimeters. So looking at labeling our sides, our adjacent is 37.2 centimeters. That's the side next to angle B. And the hypotenuse is across from the right angle. So that's the 85.9 centimeters. So we have adjacent and hypotenuse. So that's why we're using cosine. Cosine B is equal to adjacent over hypotenuse. Fill in the numbers that we know. Cosine B equals 37.2 divided by 85.9. We do that division. And again, when we write it down, we round to at least 4 decimal places. 4 or 5 decimal places is perfect. So cos B is equal to 0.4331. Again, we could, in order to figure out, to go backwards from finding what our ratio is to finding our angle, we could use the trigonometric tables. So we would look on our table and find the closest thing to 0.4331, which is 0.4384, which is an angle of 64 degrees. So using the tables, this finds us that it's about 64 degrees. But again, of course, we don't want to have to use the tables all the time. We want to use our calculators. So we're going to use the cosine inverse function on our calculators. So again, the inverse is a little exponent of -1. So we have cos -1, open a bracket of cos B, close a bracket, is equal to cos the exponent -1 of opening your bracket 0.4331, close your bracket. And this tells your calculator how to do it on how to tap into all of those, that big table that so we don't have to have it memorized or carry it around. Again, your cos inverse button is on your calculator as the second function of your cos sign of your cos button. And then if we do that, we find that our angle B is 64.3 degrees, which is what we've looked it up basically on the chart as well. And that's what all it means to do with cos, except that always, I forgot, the calculator must be in degrees. Again, always calculator must be in degrees. So now you can do your support questions on page 11, questions 12 through 14. And then finally, looking at the tangent ratio. I know this is all very repetitive as it is very similar, but slightly different, but we're going over it to make sure that it all makes sense. So our tangent ratio, we are still talking about right angle triangles. And for this one, we're going to remember that the reference angle is the important angle in the situation, and it's never the right angle. That's our first piece of information. Because now we're talking about the opposite, which is always across from the reference angle. And the adjacent, which is always next to or adjacent the reference angle. And the tangent is tan A is equal to the length of the opposite side divided by the length of the adjacent side. So tan A equals opposite over adjacent. And if you're writing in short form, tan A is equal to OPP divided by ADJ, or opposite over adjacent. And those are what I always use to write down my short forms. Some folks use this as TOA. They remember it as TOA to complete a little phrase that is SOHCAHTOA, which many folks have heard SOHCAHTOA. And so SAW being sine is opposite over hypotenuse, CA being cosine is adjacent over hypotenuse, and TOA being tan is opposite over adjacent. If this is helpful to you, great, totally use it. I was never good at spelling, so this never helped me. It just overwhelmed me, and it was easier for me to just understand logically what's going on. That was not a useful tool for me, so I didn't use it. Also, many teachers in North America have used inaccurate, racist belief systems of this, making up stories that this is an indigenous word, and have make up these terrible stories. And there's also many videos of people doing awful things in classrooms when teaching trigonometry and using this SOHCAHTOA as their to help them remember. So it's really problematic, and though the acronym isn't actually problematic, tying it into indigenous language and making fun of it or making it pretend is not okay. So that's another reason why we choose maybe not to use it a lot, because it has that racist history, which is also still present day happening. So it's not historical history, it is current as well. Anyway, if you want to talk to me about that, feel free to reach out and we can have a chat. Okay, so back to the math of it. How do we find an angle using this information? So we have a triangle, a right angle triangle with reference angle M, one side 19 centimeters, one side 33 centimeters. So we have to look at labeling. The side opposite our angle is 33 centimeters. The side adjacent to our angle is 19 centimeters. So because we have opposite and adjacent, we're going to be using tan. I forgot to mention that there's an example like this on page 15 in your IEL booklet. So now we fill in the information that we know. So tan M is equal to 33 over 19. So when we do that division, we get tan M equals 1.7368. You'll notice with tan, you do not always get something less than 0. You can get values that are greater than 1. We're not always getting values that are less than 1. My bad, said that wrong. Still use 4 decimal places to get an exact answer. Then looking at a trigonometric table for tan with 1.7368, looking on we find that the closest thing to that is 1.7321, which is an angle of 60 degrees. So this is roughly 60 degrees. So using our calculator, now we're using tan inverse, which is tan to the exponent -1 of tan M. So tan is equal to tan inverse of 1.7368. So if you put that in your calculator, you'll get your angle. Your tan function, your tan inverse is your second function of your tan button, just like sine and cosine. It's all the same with their own ratios. And we'll find that angle M is equal to 60.1 degree, which is what we found by looking at the charts. So the same thing, your calculator must be degrees, but you're basically following the same steps always when you're finding the angles, which is really nice. Now you can do the review questions on, sorry, the support questions on page 16, questions 19 through 21. So then coming back to the question of which ratio do I use? How do I know if it's sine, cosine, and tan? We're going to follow the same steps in order to figure that out, depending on the information in your question. So this is, again, one of the key pieces. Your ratios are basically, you're doing the same thing. You're just pressing a different button on your calculator to tap into those different charts, which figure out all of the ratios that exist. So you need to know which button you need to press on your calculator. So how do you figure that out is one of the trickiest things. So we have our 4 steps, which we went through in our previous part of the lesson, but we're going to go through again. So step 1, confirm your triangle is a right angle triangle. Yes, we have our symbol for right angle triangle. We are good to go. Step 2, label the sides of your triangle. So we have to know where our reference angle is. So we have a reference angle of B in this question. And we find our opposite side by looking across and writing OPP. We find our adjacent side by looking beside and writing ADJ. And then we find our hypotenuse side, which is across from our right angle. So as I said in our previous lesson, I like to label them all so that I know. You can decide if you want to label them all or not, but really labeling them all is going to be your best bet to give you information that you actually have. This also helps me that if you do label them all and you're constantly getting things wrong, I can see, is it a problem with your labeling? You don't understand which sides are actually which sides? Is it a problem with your calculation? Pressing a button wrong on your calculator? Labeling the other side gives me more information. Okay, so then once we do that, we need to, for step 3, identify what information we know and what information we're solving for. So in step 3 here, we know our adjacent side is 63. We know our hypotenuse is 75. And we don't know our angle, our reference angle B. We don't have a number for that. So that is what we are looking for. That is what we're solving for this time. So then once we know that, we choose our ratio by thinking about what all of our ratios are. So we remember that sine B is equal to opposite over hypotenuse, cosine B is equal to adjacent over hypotenuse, and tan B is equal to opposite over adjacent. So we think about, well, what do we know and what are we looking for? Well, we know our adjacent, we know our hypotenuse, and we're looking for our angle. Which one of these 3 have adjacent and hypotenuse in them? Cos does. So we'll be using cos B equals adjacent over hypotenuse. That's how we decide which one to do, because that's the information that we have. So again, this is a really, really important piece of information, screenshotting this or coming back to this part of the video so that you can really make sure that you're following all the steps to understand which tool that you have that you can use. Super important. All right, so let's do some practice questions together, as this is a lot that we've covered, and practice is how it makes sense to us. Okay, so practice question number 1, it just asks us to calculate tan inverse. So it asks us to calculate it. A is tan inverse of 5.9328. So we're going to use our calculator. So really, these are just, you really just are using your calculator to do these. So I had to go to second function to get tan inverse and then back with my numbers. So then it's 5.9328. It gives me an angle of 80.3 degrees. So then how I would, so that is equal to 80.3 degrees. Because we don't have, it doesn't tell us how many decimal points or anything like that, I would just do 1 decimal point, but generally doing angles to a whole angle is fine, rounding it to a whole number because degrees are pretty small. Okay, part B, sine inverse of 0.4271. So again, second function, sine inverse 0.4271 is equal to an angle of 25.3 degrees. And then finally, cos inverse of 0.0256 gives us an angle of 88.5. I just want to quickly show you on my calculator, see if I change it so that it's not on degrees. All of my numbers have changed and are really quite different. So now they're in what are called radians, and this is why it's really important for your angle to be, your calculator to be in degrees. Otherwise, your numbers really don't make any sense to you because we haven't learned about radians. So that was just a quick demonstration of why that's important. So 88.5 degrees. And that's how we use our calculator. All right, so then here, number 2 says to calculate angle N to the nearest degree. So what I want you to practice on is remembering your proper notation. So this is something that students often struggle with. So if you are writing out all your steps, which as we know, I always encourage, how you write this out is, so my part A is sine N equals 0.5922. So how you would write this out is to do the inverse. It's like when we're isolating for N, we have to do the inverse, just like when we're adding and subtracting, multiplying, dividing. We've done exponents, right? We're doing the inverse. So the inverse of sine is sine inverse. And then you, inside your bracket, you have sine capital N. So if you do it to one side, you have to do it to the other side. And this is one of those things where your way you write it out really communicates your understanding. And though it's possibly not something that you're going to be doing it a lot in your life, sure, but paying attention to detail is a really important skill. And so following these steps really shows that you can pay attention to detail and notice those nuances. Otherwise, it might not make any sense. So like if you write sine N equals sine inverse of 0.5922, that doesn't make any sense. So don't write it like that because it doesn't make any sense mathematically. So just be careful with that when you're writing your things down. So if we then actually do sine inverse of our number 0.5922 is equal to 36.3 degrees. So then you write angle N is 36.3 degrees. This symbol here that is your angle sign symbol, so it's like kind of like a triangle with but leaving off one side is your angle sign. So that's what that means. Okay, so then for part B, cos N equals 9 divided by 13. So we could do that division, or we can just leave it in our calculator. We can put the calculator can handle doing the cos inverse of 9 divided by 13. So if we do that on our calculator, instead of writing down, having to round it off and write it down, we can get an exact answer by putting in cos inverse of 9 divided by 13. Sorry. So then that gets us to 46.2 degrees. So angle N is equal to 46.2 degrees. And the same with tan, part C, tan N equals 35 divided by 29. So tan inverse of tan N is equal to tan inverse of 35/29. As we already know, probably, hopefully, I'm a fan of just doing it all on my calculator to make sure that I'm not having any rounding errors. But of course, you can divide it and then do it on your calculator if you need to. So that is 50.4 degrees. So that's how we calculate when we calculate our angles. All right, so here we have another question. Calculate angle F. We have a triangle that's a right angle triangle where F is our reference angle. We have one side, which is 12.1, and we have the other side, which is 8.4. So we need to figure out in relation to our reference angle, F is our opposite side is 8.4. In our adjacent angle, our adjacent side is 12.1. So because we have opposite and adjacent is tan. So tan of F is equal to opposite over adjacent. You don't have to have this memorized. You can look it up. That's okay at this point. You need to be able to apply it. Something that having it in your head is really useful. But it's okay at this point if you need to look it up to get you comfortable doing it. That's fine. So I put in the numbers that I know. So tan F is equal to 8.4 divided by 12.1. So tan inverse of tan F is equal to tan inverse of 8.4 divided by 12.1. So angle F is equal to, using our calculator, tan inverse 8.4 divided by 12.1 is equal to 34.8 degrees. So this angle is 34.8 degrees. All right, number 5, calculate y. So we have a right angle triangle, our first check. I don't want to do this because this is we're finding a side. Well, actually, let's do it to practice it so that because we haven't done it in a while. So that's fine. We'll practice finding the side. Okay, so we know our reference angle this time is 28 degrees. The side opposite is y, our unknown, and our hypotenuse is 173. So because we have opposite and hypotenuse, that is going to be sine. So sine 28 degrees is equal to, sorry, I should do it like this. Sine A angle is equal to opposite over hypotenuse. So sine of 28 degrees is equal to y over 173. Multiply both sides by 173 means that we have 173 times sine of 28 is equal to y. So then if we do that on our calculator, 173 times sine of 28, which is 81.2. So the side length of y is 81.2. So as you can see, they're not really different. Finding an angle or finding a side, the setup is the same, and then you just are solving for what it makes sense to solve for. If that was really confusing to you, go back and watch part 1 of lesson 11. Okay, let's do a word problem. Number 6, Caleb uses a wheelchair. The ADA guidelines suggest that a safe, accessible ramp doesn't have an incline greater than 5 degrees. Caleb wants to enter a store that has a ramp that is 6.1 meters long and has a rise of 0.4 meters. Is this store accessible? So, as always, if we don't have a picture, let's draw one. So we have the ground, we have the store, and we have a ramp. We have a ramp going into the store. The ramp is 9 degrees to the store. We assume the store is straight up and down to the ground. We know that it is 6.1 meters long and has a rise, so it goes up 0.45 meters. And we're trying to figure out, is the ramp accessible? So is this angle here, A, where the wheelchair would start, would that is that going to be greater than or less than 5 degrees? So if we have A, we have our opposite side is 0.45 and our adjacent side is 6.1. So we have opposite and adjacent. That means we have tan. So tan of A is equal to opposite over adjacent, which is equal to 0.45 divided by 6.1. Sorry. So then we have to do tan inverse of tan A is equal to tan inverse of 0.45 divided by 6.1. Again, you always can divide that if that is better for you. So then on my calculator, I'm going to do tan inverse of 0.45 divided by 6.1, and I got an angle of 4.2 degrees. So have I answered the question? No. The question is this store accessible? So they can't be bigger than 5 degrees. We have 4.2 degrees. So yes, this store is accessible. Well, at least the front door is accessible. All right. Number 7, we hopefully can fit in. Let's see. A rescue helicopter sights a boat in distress at an angle of 40 degrees from the horizon. Horizontal, sorry. The helicopter is hovering 400 meters above the water. How far must the helicopter travel if it flies in a straight line to rescue the boat? So the thing with these ones is that they can be really tricky to understand what it is going on. So we have some water. Doesn't matter what it looks like. We have a helicopter. Again, it doesn't matter what it looks like. Beautiful drawing. You can enjoy the fact that you can make beautiful drawings. We have a boat in the water. So when it says that there is an angle, a rescue helicopter sights a boat in distress at an angle of 40 degrees from the horizontal. So what that means is that this, if you're looking straight out and you look down, that angle is 40 degrees. So then it says if the helicopter is hovering 400 meters above the water, how far must the helicopter travel if it flies in a straight line? So how far, if it flies directly towards the boat, does it going to have to travel? Again, because we said it's directly above, the water is 400, the helicopter, that part is an angle of 90 degrees. And so now we have a right angle triangle. So this is the tricky part, is that is our angle inside of our triangle? No, it is not. So we have to figure out what our angle is, which is in here. And between the horizontal and straight down is also 90 degrees. That is how the horizontal is defined. So angle A is equal to 90 degrees, take away 40 degrees, which is 50 degrees. So angle A is 50. So sometimes you need to figure out more information opposed to what is just given to you. That's really hard to understand. There we go. So now we can figure out, so our opposite, we don't know, our adjacent is our 400 and our hypotenuse is what we're looking for. So if adjacent and hypotenuse, that's going to be cosine. So cosine of 50 is equal to 400 over your hypotenuse. So I'm going to do this a little bit quickly because we're running out of time. Your hypotenuse is equal to 400 divided by cos 50. That I just multiplied both sides by hypotenuse and divided by both sides by cos 50, which is fast, but we're running out of time, so sorry. 400 divided by cos 50 is equal to 622 meters. So this was a finding a distance one again, but we were able to, just by putting information that we know and we don't know, we were able to find it even though that wasn't our focus. So the helicopter must fly 622 meters. And there we go. All right, let's quickly consolidate before we're out of time. So we've wrapped up lesson 11, our trigonometric ratio lesson. So our focus is looking at sine, cosine, and tangent, which are called the primary trigonometric ratios. As you've seen, labeling your right angle triangle is essential. Understanding where your opposite, your adjacent, and your hypotenuse and your reference angle are is super, super important. SOHCAHTOA is something that you can use to help you remember, remembering that sine of your angle is equal to opposite over hypotenuse, cosine of your angle is equal to adjacent over hypotenuse, and the tan of your angle is defined by opposite over adjacent. We now can solve for the unknown side, and we can solve for the unknown angle. Remember, you have to use the inverse function for solving for the unknown angle. So it's a lot in both of these lessons. It can be confusing. If you're unsure, please reach out and let me help you. Always, your calculator must be in degrees in order for you to be talking about the thing that we're talking about. So super, super important, because you can be doing all the math correctly, understanding it all correctly, but your calculator can give you the wrong answer if your calculator is not in degrees. Super important. Okay, so hopefully you can identify the opposite, adjacent, and hypotenuse sides in a right angle triangle. You can solve for unknown sides using trig ratios, and you can solve for unknown angles using trig ratios. That's what we had hoped to accomplish in this lesson. As always, if you have any questions, please reach out. This is how I'm here to support you. This stuff is kind of abstract and can be confusing, so please let me know how I can help you by connecting. Give me a call at the office at 807-737-1488, extension 2209, or call toll free at 1-800-667-3703. Send me an email at bronwyn.slate, that's spelled BRONWYN.SLATE@nnec.owen.ca. Send me a message through Facebook where my name is B Slate Wahsa. Check out this video and all of my other videos on YouTube, which is also called B Slate Wahsa. Remember, all of our lessons are under the playlist MBF3C, which is our course code. I am here at the office Monday through Friday, 9 a.m. to 3 p.m., except on Thursdays when I'm in from 10:15 to 4:15. So please connect if you need support. Thank you so much for joining me today. Have a lovely day. Miigwech.